There's a ticking time bomb in the sky, and it might have already gone off. For centuries, it's hovered quietly above our heads, a bright red glow sitting on the shoulder of Orion. Most people don't give it a second glance, but astronomers, they've been staring at it with growing unease, because this isn't just a pretty light. It's a supergiant, one that's guaranteed to explode. The only mystery is when, or whether we're already too late to see it coming. And here's the craziest part. When this explosion finally reaches Earth, it might be the most spectacular thing we've ever seen in the night sky, or the most terrifying. It's called Betelgeuse, a name that sounds strange, almost playful. Betelgeuse is a red supergiant, one of the largest types of stars in the universe. To the naked eye, it's just a tiny dot, but in reality, this thing is a monster. If you placed it where our sun is, it would stretch out past Mercury, past Venus, past Earth and Mars, maybe even all the way to Jupiter. We're talking over 700 times the size of the sun. A single star so huge, you could fit over 1.6 billion suns inside it and still have room to spare. But that size comes at a cost. Betelgeuse is bloated, unstable, and rapidly burning through its fuel, like a balloon stretched to its limit. And when that balloon finally pops, it's not going quietly. Every star has a lifespan, and Betelgeuse is near the end of its own. For most of its life, it's been fusing hydrogen into helium, creating energy in a steady, stable process. But eventually, the hydrogen runs out. The star then starts fusing helium into carbon, carbon into oxygen, and heavier elements beyond that. Each stage happens faster than the last. Right now, Betelgeuse is deep into this late-stage chaos. It's already cycling through the heavy stuff: silicon, sulfur, maybe even iron. And that's the final stop. Because here's what makes iron different. It takes more energy to fuse than it gives back. The moment a star like Betelgeuse starts forming an iron core, it's like a trap door slamming shut. The fusion stops. The core collapses, and in the blink of an eye, the entire star implodes, triggering one of the most powerful events in the cosmos, a supernova. In late 2019, something strange happened. Betelgeuse started to dim, and not just a little, it dropped to less than half its usual brightness. For a star this massive and prominent, that was alarming. Telescopes around the world zeroed in, and panic started spreading through the astronomy community. Was this it? Was Betelgeuse finally going supernova? Theories flew in from every direction. Some thought it was just a surface cooling event. Others suggested it might be collapsing right before our eyes. But then, data from the Hubble Space Telescope revealed something unexpected: a massive cloud of dust. It looked like the star had burped out a chunk of itself, forming a cloud that temporarily blocked our view. Crisis averted, for now. But the event left scientists rattled, because while the dust theory makes sense, it also confirms something unsettling. Betelgeuse is unstable, and it's capable of wild behavior we don't fully understand. Here's where things get even weirder. Betelgeuse is around 640 light-years away from Earth. That means the light we're seeing from it right now actually left the star in the 1300s. We're not seeing it as it is. We're seeing it as it was during the medieval era. So if Betelgeuse has exploded, it could have happened centuries ago, and we're just sitting here, waiting for that light to reach us. Every night, astronomers scan its glow, watching for flickers, changes, signs. But in reality, they're watching a ghost, a centuries-old recording of a star that might already be gone. It's like space is holding its breath. And when that breath finally exhales, the entire sky will know. When Betelgeuse finally explodes, here's what we'll see. First comes a wave of neutrinos, tiny, nearly massless particles that flood the universe from a supernova. We won't see them or feel them, but detectors around the world will light up in an instant. That'll be our first clue. Then, a few hours later, boom. A flash of light so bright, it will outshine every star in the sky, possibly even rivaling the moon. It'll be visible during the day, it'll cast shadows at night, and it'll stay that way for weeks, maybe even months. For people on Earth, It'll feel like watching history happen in real time, the death of a star, unfolding before our eyes. And whether you're a scientist or someone who's never looked at the sky, you won't be able to ignore it. The word supernova sounds terrifying, and it is if you're nearby. An exploding star can unleash more energy in a few seconds than our sun will emit in its entire 10 billion year lifetime. The shockwave can rip apart planets, the radiation can fry atmospheres, and the gamma rays, they're the real killers, invisible beams of pure destruction. But here's the good news. We're not close enough. Betelgeuse sits at a comfortable 640 light-years away. That's far beyond the danger zone. For a supernova to truly threaten Earth, it would need to happen within about 50 light-years. At our distance, the explosion will be dramatic, but not deadly. Still, that doesn't mean we'll get off without any effects. There could be subtle ripples, increased radiation in the upper atmosphere, maybe some interference with satellites or power grids. But the biggest impact will be psychological, the feeling of watching a cosmic titan die right above our heads. Here's the strange beauty of it all. A supernova is violent, yes, but it's also a beginning. When Betelgeuse explodes, it won't just vanish. Its outer layers will scatter across space, creating a glowing cloud of debris, a nebula. And at the center, something far stranger will form, either a neutron star, a city-sized core of crushed atoms so dense it bends space itself, or, if the collapse is deep enough, a black hole. That's the ultimate paradox. A supernova marks the end of a star's life, but it also plants the seeds for new ones. The elements created in the blast, oxygen, carbon, iron, they'll drift through the galaxy. One day they might help form new planets, maybe even life. In a way, everything we are came from events like this. The calcium in your bones, the iron in your blood, all born in the heart of a dying star, maybe even one like Betelgeuse. Now here's the question that really haunts astronomers. What if it's already happened? Remember, we're seeing Betelgeuse as it was 640 years ago. If it exploded any time after the 14th century, we wouldn't know yet. Not until the light reaches us. So when you look up at that reddish glow, you might be looking at the afterimage of a star that's already gone. That's what makes it so eerie. Every night, scientists scan the sky, waiting. Observatories run nonstop. Telescopes stay locked. Because when the moment comes, we won't get a warning, just a sudden blinding flash. And once it starts, there's no stopping it. It's cosmic roulette, and the wheel might have already landed. In science, timing is everything. But with Betelgeuse, time plays tricks. It could explode tomorrow, or next year, or in a million years. On the scale of the universe, those are all the same blink. It's like standing in front of a ticking bomb that may have already gone off, or may never go off at all. And that uncertainty, that's what makes this star so legendary, because it forces us to confront how little control we really have. A star, 600 light-years away, could light up the night sky at any moment, and all we can do is watch. Here's the final twist. When Betelgeuse goes supernova, it won't just be a one-time event. It'll change how we see the sky forever. That spot in Orion will glow for months, maybe even a year. Then slowly, it'll fade. The familiar constellation will never look the same. It's like losing a landmark. Generations from now, people will look up and see an empty shoulder where Betelgeuse used to be, and they'll talk about the time the sky lit up. And the story won't just live in textbooks. It'll live in songs, art, myths, the night humanity watched a star die. Astronomers know that when Betelgeuse finally explodes, it will be more than just a spectacle. It will be a rare, once-in-a-lifetime opportunity to study a nearby supernova in real time. For the first time in human history, we'll have telescopes, satellites, and sensors ready to capture every stage of the event, from the neutrino burst to the shockwave aftermath. The data could reshape our understanding of stellar evolution, element formation, and the life cycles of massive stars. It might even help us predict the fate of other giants scattered across the galaxy. In the death of Betelgeuse, Science won't just observe, it will advance. We don't know when it will happen, but one day it will. And when it does, the universe will remind us just how small we are and how breathtakingly beautiful that can be. The next time you step outside on a clear night, look toward Orion. Find that red star and ask yourself, are we watching the past or waiting for the future to arrive? Because one thing's for sure, the show of a lifetime is coming. And when it does, we'll all be watching.